Hello, welcome friends. In this session, we will simulate a simple RC circuit. After simulation, what is to be observed, I will explain you. Okay. So, let this be the RC circuit supplied by DC voltage. This is source voltage. This is RC circuit. RC. And we are observing the voltage across this capacitor, instantaneous voltage V, and let this be the supply voltage, DC supply voltage V, capital V. So when we observe this voltage across capacitor and plot against time, so this will be the graph of approximate graph of V versus T, or x-axis T, y-axis T. So what is time constant? Time constant is the that time which require to charge the capacitor up to 63.25% of supply voltage. So this is 63.25% of V, and this is time constant T, capital T. Okay. So mathematically, what is the value of time constant T? T equal to R multiplied by C. For simulation purpose, we will select R equal to 10K, R equal to 10K, and C equal to 100 microfarad. Please note that this R and C are very practical values. That means such component you can have from market very easily. Okay. So what is the time constant T now? T equal to 10 multiplied by 10 to the power 3 multiplied by 100 into 10 to the power minus 6 equal to 1000 into 10 to the power minus 3 equal to 1 second. So we will make this circuit in MATLAB Simulink, and we will run the simulation for nearly 5 seconds so that we will have the a good graph. Okay. So now we will turn to MATLAB. So close this, don't save, and open this MATLAB. Under MATLAB, Simulink, under Simulink, start the blank model. We have kept this library open. So go to library, and in library from specialized power system, select this passive power, passive component. R and C are passive components. So series RLC branch, select series RLC branch and drop that RLC branch here. Rotate by right clicking, rotate, format, and rotate clockwise. Please note that here this is RLC. Out of these, any two or all three we can keep. The second thing to be noted that we can't connect voltmeter in between here. So only by eliminating this inductance, we can't have RC network properly because we can't measure the voltage here. So only we will keep here C. So double click here, and instead of RLC, select C and give its proper value. that is 100 e to the power minus 6, that is 100 microfarad. Apply. OK. You can copy this block. So Control C and Control V. Now instead of here capacitance, you will select the resistance. So instead of capacitance, select the resistance, and that to 10 3, that is 10K. Apply. OK. Now you will require voltage source. So again, go to library, and please note that again there are sources at so many places, but you have to select the source from respective library. So go to here sources, and from here you can have this DC voltage. So it is simplest one. Uh, don't go for at first stage any complications. So this is simplest voltage source, and its value is 100 volt. OK, and connect this voltage source to our network components. Now we have completed the circuit. To measure the voltage, you have to go in sensors and measurement. From sensors and measurement, you will select voltage measurement. Keep this voltage measurement block here and connect its input terminal here and here. Okay. To plot the voltage, you will require scope block. That scope block is this is commonly used block under Simulink, commonly used block. This is the scope where you can monitor the graph. So put that scope here, okay, and connect this scope to this much. You require one more block, that is power GUI module. It is available in respective library, specialized power system. There are under this library there are so many sub libraries. All these are sub libraries, and this power GUI common block is separate here. So drag and drop this common GUI block. Now you will simulate this for nearly 5 seconds. So instead of stop time 10 seconds, here enter 5 seconds. 5 seconds is sufficient. So now start the simulation. It will run the simulation properly. Okay, simulation completed, and double click on the graph to check whether it is not getting properly. Why so? Because we have forgotten to add the initial condition to this capacitor block. That means capacitor should be initially discharged, that is having 0 voltage. So go here, set the initial capacitor voltage. Now it is 0 volt. Apply. OK. Again run the simulation. OK, and observe the graph. OK, fine. Now you have got the proper graph. Shape is proper, but you have to measure the at 1 second whether expected voltage, that is 63% of 100, that is obviously 63 voltage you are getting or not. So maximize it and open this scale tool. Okay, you will get two cursors for measurement, and here are the actual measurement. So drag this to 1 second. Observe here, this is the 1 second. Drag this to 1 second. Okay, this is 1 second. 1.006. You can have some fine adjustment. Okay, 1.002. You have got 1.002, and you have got 63.25. That is 6.325 into e to the power plus 1, that is 63.25 value. That means your simulation working properly. Okay, Thank you. We will close this. I am not going to save this. Okay, no. Thank you.